Part 2 of Unit 2 is about balancing reactions. If you remember the law of conservation of mass, it says that matter is never created or destroyed. We have to apply that to chemical reactions. We have to make sure that we've got the same amount of atoms on the reactant side of the equation that we do on the product side of the equation. And we do that by adding coefficients to the products and reactants to multiply by subscripts and make sure we have the same number of atoms on each side. So let's just look at this example. We've got aluminum carbonate being heated and breaking down into aluminum oxide and carbon dioxide. So this is a decomposition reaction. First thing we have to do is be able to write the formula for everything. So aluminum carbonate. Aluminum has a +3 charge, so we drop a 3 down here. Carbonate's got a -2 charge, so we put a 2 right there. Remember, we have to put in parentheses to make sure it's not 33 oxygens. So that's our reactant, and it's going to be heated, and it's going to break down to aluminum oxide and carbon dioxide. Carbon dioxide is the easy one. We'll put it first, and then aluminum oxide, it's going to be the same concept as aluminum carbonate. -2 for oxide goes here, and the +3 for aluminum goes there. So this is our skeleton equation. We have to go back and balance it. Right away, we can just start with aluminum. There are 2 aluminum atoms on the reactant side, and there's 2 on the product side, so we don't need to add anything for aluminum. We've got 3 carbon atoms in aluminum carbonate right here. This 3 outside the parentheses, we multiply everything inside it by 3. So 3 times 1 is 3. We got 3 carbons there. There's only 1 carbon on the product side, so we have to throw a 3 in right there. So we get our 3 carbons from the subscript here and 3 carbons from the coefficient right there. Now for oxygen, it's always a good idea to save oxygen for the end, no matter what reaction you're balancing. We've got 3 times 3, that's 9 oxygens on the reactant side. Let's see how many we've got on the product side. 3 times 2 is going to be 6 oxygens from carbon dioxide, plus the 3 oxygens from aluminum oxide, so 6 plus 3 is 9. All we had to do to balance this equation was throw in this 3 right here. Let's look at another example. Aqueous sodium sulfate and barium nitrate are combined, producing sodium sulfate or sodium nitrate and barium sulfate. This is a double replacement reaction. We got sodium sulfate. Sodium's got a +1 charge. Sulfate's got a sulfate has a -2, so we have to put a 2 down there to balance it. And it's going to react with barium nitrate. Barium has a +2 charge, so we have to throw a 2 down here. Nitrate's got a -1, just leave our understood 1 there and put our parentheses around it. And I've run out of room, so I'll just write the products down here. We're going to get sodium nitrate. So basically what's going to happen is sulfate and nitrate trade places. So nitrate's going to come hang out with sodium. +1 and -1 charge, so that's all we need to write. And we're going to get barium and sulfate hanging out together, +2 and -2 charge. So there's our skeleton equation. We need to go back and balance it. Right off the bat, we've got 2 sodiums on the reactant side, but only 1 on the product side, so we have to throw a 2 right here to balance out the sodiums. Polyatomic ions can be balanced as a unit if they're not broken up. See, sulfate stayed together on both sides of the reaction, so we don't need to balance sulfur and oxygen separately. We can just balance SO4 as a unit. We've got 1 SO4 on the reactant side and 1 SO4 on the product side, so that's good. There's 1 barium, that's all we have to do. Remember, this 2 means there's 2 nitrates. You could say it's 2 nitrogens and 6 oxygens, but since NO3 stayed together, we can balance it as a unit. There are 2 nitrates on the reactant side, and since we put this coefficient of 2 in front of sodium nitrate, it applies to both sodium and NO3. So 2 times NO3 would make that one balanced as well. So that one was also fairly easy. Really, this should be fairly easy review for you. Combustion reactions sometimes can get kind of difficult to balance. Let's see, propane is completely combusted in air. So propane is C3H8, that's our hydrocarbon. I put this in air on there to remind you that we have to have oxygen as a reactant in a combustion reaction. If there's no air, nothing can burn. And it's completely combusted. That means it's going to make CO2 and water. If it was incomplete combustion, it would be just CO, carbon monoxide. When you're balancing a combustion reaction, save oxygen for the very end. Do carbon, then hydrogen, then oxygen. We got 3 carbons with propane, but only 1 over here with CO2. So put a 3 right there. 8 hydrogens on the reactant side, only 2 on the product side. We'll put a 4 here, so we get 4 times 2 equals 8 hydrogens from the water. Now we've got 2 oxygens on the reactant side. Let's look on the product side. We got 3 times 2, that's 6 oxygens from carbon dioxide, and 4 times 1, that's 4 oxygens from water. We add these together, we're looking at the total number of oxygens. 6 plus 4 is 10. We can get 10 by throwing a 5 right there. If it ever works out that you have an odd number of oxygens on the product side, and you would have to put something like just as an example, a 5.5 as a coefficient for an O2 to balance it out, what you do is you double the entire reaction. You go back and you put a 2 in front of your hydrocarbon. You take that invisible 1 and replace it with a 2. Then you can double your O2. That would become an 11. You double this 3, it becomes a 6. And you double this 4, it becomes an 8. Again, that does not apply to this specific reaction. We had this one balanced the first time with just the 5, 3, and 4. But if you ever end up with an odd number of oxygens on the product side and there's not a factor you can multiply by 2 to get your oxygens to balance, try multiplying the entire reaction by 2. In the question for this section, solid zinc is added to a solution of copper 1 nitrate. Write and balance the reaction. Do your best to type it in to the answer box.